Okay, here's the third example, which is the third part we discussed that we talked about that we are going to solve. Now, the thing here is that let's apply the same principle we have been applying. As we said, here are the steps, right? The step for solving it, but I'm going to explain it here now. Let's do the same thing. Let's do the same thing here. The first thing we need to do is that, as we usually do, we take the absolute value of this signal, right? So let me write solution here. So then, after we take the absolute value of the signal, it is the same thing, right? Because there isn't any negative value. At the minute there's a negative value, it becomes positive. So we need to what? Take the square of this absolute value, which is going to give us what? Tu of t squared. And it's going to be called t squared u of t, right? All squared. Now, remember that u of t squared, this is u of t. We discussed about this kind of signal, right? U of t is a step function, and it's having a value of what? 1. So since u of t is a step function, is having a value of 1, definitely if you square 1, it's still going to give you 1. So u of t squared is the same thing as u of t. So definitely this results in what? T squared u of t. Right? So if this results in t squared u of t, the next step, which is the third step, right? We did this, is to what? Take the integral from negative t to t of what? X of t squared. Never forget the dt as always. So this same thing as what? Negative t to t, right? The same thing as negative t to t. This x of t here is the same thing as this. So we have t squared u of t dt. Now, to ease it for us, right, we know that u of t is defined from 0 to t, which means from negative t to 0, u of t is 0. I know u of t is a mixture of the signal. So which means even though we mix the signal together, it is going to what? Give us 0. So there's no need of calculating for this negative t to 0. So we can remove it from this signal and negate the u of t. Then definitely this means that since u of t is defined from only 0 to t, we just have, right, it's then from negative t to t, we just have t squared dt, which means u of t has what? Truncated the signal. So since this is the case, right, let's find the integral. The integral of this is going to give us what? T cubed over 1 3 from 0 to t. That ends up giving us what? T cubed over 3 minus 0, because if we substitute, we end up having 0. So since the integral from negative t to t of what? X of t, right, squared dt is equal to t cubed over 3. To find the energy part of this signal, all we just need to do is take the limit as t tends to infinity of what? This integral. Alright? So what is it? It is t cubed over 3. So let's substitute infinity. We have infinity cubed over 3. The same thing as infinity. Definitely energy is equal to what? Infinity. What about power? We know that power is quite similar to what? And the difference here is that we put 1 over 2 t here. So this limit what tends to infinity, 1 over 2 t, right? Then t cubed over 3. So we end up having what? The t here will cancel 1 of the t here, so we have squared. So we have t squared over what? 2 times 3 is equal to what? T squared over 6. Likewise, if you substitute infinity, we end up having infinity squared over 6, which is same as infinity. Definitely power is also equal to infinity. So if energy is equal to infinity and power is equal to infinity, then such kind of signal is what? It is neither power nor energy signal. So I hope this clarifies it. The first section, the first part of this video, we discuss about some tricks that we use in solving it. We will also discuss about signals that are energy signal and the power signal, and those that are not, that are neither energy nor power, and we also solve an example. So in the second part, we solve an example of power signal, because the first part is for what? Energy signal. The second part is on power signal. Now this one is what? Neither power nor energy signal. I hope the concept is clear. If there's any question, as usual, feel free to ask in the comment section. Cheers.